This is All Robotics Competitions, and I'm your host Kiril Mitov. Today, again, I'm joined by Will. Will is one of the founders of US Engineering Clique, which was established in 2018 and has been the national organizer for the World Robot Olympiad in USA since 2020. And we've done a couple of videos already with Will where we went into details about World Robot Olympiad 2023, along with the rules for elementary and what you should do at the elementary and for the unofficial We Do competition. Today our topic is Junior, the junior competition in the World Robot Olympiad 2023. Hi Will.
Hi,
Nice
how are
to
you?
meet you again.
Good.
Last time we discussed We Do. It was an unofficial competition, and it was for students that are small, young, at the age of 6, 7, 8, 9 years old. But today is the junior. Help us understand the junior competition.
Sure. So this is the Robo Mission Junior category. Again, it is a table-based competition where teams ages 13 to 15 have to complete some missions, and this year's missions are just as challenging as past years.
Last year they were quite challenging. I remember they were quite difficult, and for this year any changes, it's again 2 minutes that you have for the competition and for every round, and you have 3 tries.
Correct.
And they can use all kinds of robots as long as they are Lego robots. So
As long as the Lego,
Prime.
Spike Prime and EV3 are the ones we usually see.
What do you think about this year season?
For the junior or
For the junior, yes.
Yeah, it's challenging. So what we're seeing is, it's a little challenging for teams with the Spike Prime because of the number of ports. When we go over the rules and the challenges, we'll kind of talk through why it's challenging for the Spike Prime users. It can be done, but and most of my teams here in the Chicago area are using Spike Prime, but a lot of them are considering the EV3 because of the additional ports.
Let's talk about this a little bit more, because we've got a number of questions on this topic. So Spike Prime, it has 6 ports, right?
Correct.
And EV3, it has 8 ports.
8 ports. Now,
And where does this difference come from, and what's the impact of the competition? What do
well,
you think
the
will be
EV,
the impact?
yeah, the EV3 has 8, but they're all 4 and 4, meaning 4 motor ports and 4 censored ports, and those are fixed. You can't, have 7 and 1 if you wanted to. You can't do that. But with the Spike Prime, you do have 6 ports, but they're hybrid ports. They can be either motor or sensors. But what we're seeing for the junior challenges, there's possible a need for extra ports for either a motor or a sensor, and teams are trying to figure out how to do it with only the 6.
Yes, and for the EV3, if I remember correctly, the motion sensor, the gyro sensor, was a sensor that was external to the brick,
Yeah.
while here the motion sensor is embedded in the brick.
Yes.
So you kind of get one sensor given because it's inside of the brick, and there is like a 1 port difference between EV3s and Spike Prime.
Yeah. Possibly. I think if you use the gyro sensor, because I think a lot of users of the EV3 from last year or years past did not use the gyro sensor, or at least the Lego version of the gyro sensor, because it was a little unreliable. The Spike Prime gyro sensor is good actually when it works. Actually, it's a little glitchy too, but it does work a lot better than the EV3 version. Yes.
Oh yes, it works a lot better. And last time we discussed that probably that's a strategy for We Do, but is it allowed on this competition to take 2 bricks?
No, you're only allowed to use one hub or 1 brick. Yeah.
1 hub, 1 brick. So you can't build much more, like
No.
2, 3 bricks and bring this whole thing on the
Can't daisy
competition.
chain bricks. No.
You need. Okay, tell us more about the rules. What are the
Okay,
rules for
sure. Let
this
me.
year?
I'm gonna pick up my camera and go through it. Okay. So this year's challenges on Junior is addressing communications and the setup of communications around the world. So there's in the world today, there's cabling and there's satellites that are set up, and this Junior challenge is the teams have to lay cable, place servers, and fix a broken cable and raise solar panels. So I'll kind of go through that and kind of go through the rules, and the randomization always is something that's part of the WRO, and we can kind of go over what that means.
But it's difficult to hear you from there, Will.
Okay.
We need to hear you from there, but it's
All right.
kind of
So hold on one second. Let me. Okay. So hold on one second. So did you hear that, or should I go over that again?
let us fix the audio and then we can continue. For those of you joining us now, we had some issues with the mic. We had to set it up right, and it's always a challenge when we record these videos, but now we have the mic correctly set up. It's much better, and it gives the Will the chance to move around the field and explain, and we can hear what he's talking. So Will, we were about to talk about the rules about this year World Robot Olympiad 2023, the Junior Challenge.
Yeah, so the junior rules, the Robo Mission junior rules, is the theme about it is to lay, it's about communications, worldwide communications. And in order to have worldwide communications, you need to lay cables and set up servers and look for a broken cable and set up solar panels. So we have to set up the communications. So I'm going to take the camera now. I'm going to show you on the mat what that means. Okay. So this is the starting area for the robot. It's a 25 centimeter by 25 centimeter by 25 centimeter size limit for the robot. What we have is a index or a kind of a grid for, and this is randomized. So right now, I'll just kind of jump here and I'll come back to that. We have cables, which are the white cables, and the black ones are the servers, and they have to be delivered to two different areas, the Caribbean side and the Pacific side. So we have on the mat, we have the Caribbean side, which is, there's 4 different spots, 1, 2, 3, and 4. And then we have the Pacific side as well. We have 1, 2, 3, and 4 as well here. So those, there's going to be a white cable and a black server to be delivered to each side of the oceans, the 2 ocean sides. And what we have is this index randomized to tell us where to drop them, but the robot, the competitors don't know. The robot doesn't know until until it reads this grid. So what it is the black represents the server where the drop off is, and the white, and this is for the Pacific side. That's for the Caribbean side. And for example, this one says I have to drop off the black cube to number 2 and the white to number 4. And for the Pacific Caribbean side, we have white to number 2 and black to number 4. So for example, I'm going to grab these as if the robot would, right? So you have these black and white cables, and I'm going to just deliver it to the Pacific side. So the Pacific side, it said we had to put the white on 4 and the black on 2, right? So white on 4. Now it has to be completely in the white lines. You get partial points if it sticks out a little bit, but you get full points if it's totally in. So that's full points there for that one. You get full points for that one as well. And again, they have to be completely in. You get actually bonus points if you get both of them in as well. So that's what you have to do for each side. So the other one, we had to deliver the red side, which is the Caribbean side, white to 2 and black to 4, right? So it's hard for me to reach. So I'm gonna set it up here in just a second. Let's see if I can set this up. Just give me a second.
Okay.
Yeah, it's hard to reach. So
It's a big mat. It's a big field.
so basically, we have to deliver the white one to number 2, and which was where that red one is, and the black one has to go to 4. Okay, so it has to go over there to 4, which I can't reach. But
Okay, so let's summarize the idea. So we have cables and we have servers, right? And first we need to build the robot and to program it to go and to scan the field and to see where we have to bring the cables and servers. And because Panama, which is now hosting the competition, the finals, they are both on the Caribbean and on the Pacific side. What we need to do is to, let's say, connect the cables. And the robot then, after scanning and seeing where the cables are and when the servers are, needs to bring them either to the Pacific side or to the Caribbean side.
correct. And
Perfect.
so I've correctly placed the white cable and the server right and for that, and it's hard to do. I mean, I'm trying to place it by hand. It's hard. I mean, a robot has to do it. And then there's also this red. It represents a broken cable. That red broken cable is always going to be on the Caribbean side, and the robot has to find this cable. It's randomized. You don't know if it's going to be in one spot, 1, 2, 3, or 4. So that red one right now is in number 1, and the robot actually has to pick it up and bring it to the maintenance area over here, the recycling area. This side of the back. So
Okay, so we are explaining this for, I don't know, 6 minutes, 7. How is the robot supposed to do this in 2 minutes?
it's tough, and we haven't even talked about the solar panels, right? The
Oh.
solar panels up, flip them up, and it has to do both of them. It's a tough challenge. The challenge is picking these up, right? These are loops, so they have to be picked up with it's kind of a picking mechanism. Teams can bring one at a time, but that will take time. It's probably not efficient to get it within the 2-minute time period. Then you also have to figure out how are we going to identify the red one, right? Which I dropped off over there. It's hard to figure out, and also how do you do this with a certain amount of sensors? Because you're going to use one sensor probably set to the left to read those index blocks, right? Which I'm trying to find right there. So those index blocks, you're gonna have to set a sensor there.
Yes.
But then so if you think about it, you have 2 motors, 1 sensor, and then maybe a line sensor. So have sensors facing downward to read the lines on the mat. So now you're using maybe one, maybe a lot of teams use 2 sensors. So now you have 3 sensors and 2 motors for the motor port for the drivetrain, and you need a picking motor to pick these things up by the loops. So now we've used 6 ports. We don't have any more ports to use. So it's a difficult challenge for at least Spike Primes or even EV3s trying to figure out how what motors and what sensors to use to identify these objects and to carry them to their places.
So the biggest challenge here will be how to do this with 6 ports. So this is kind of like what I'm getting. But we missed to describe the solar panels and the other parts of the mission.
Yeah. So the solar panels, there's just a lever that you need to pull down and set up the solar panel. So there's 2 of these right in here, right? So there's one. So I basically, that is a start and that's the finish. So you get points just to put it down. And that's the same thing on that one as well. Okay? Now the field is set up.
Okay.
If you look at the field at like a high level, right? Um, if you look at it, you start here, and then you go around. So then you pick it up over in that red area, the storage area. Then you can go to the Caribbean. So it's kind of like a clockwise. A lot of teams will go clockwise around the mat and then come back to home. But there's a lot to do, and you have to avoid these walls as well in the middle. These are if you move these walls, you get penalty points. So there's 120 points total, and it's not easy because we have the cables are different sizes, right? The black and white cables are different sizes, and we have the red. How do you carry that while you're going to the Pacific side and have to drop off the white and black? So, it's a sequencing and logic challenge to figure out how do I, pick up and drop off and identify where objects are and dropping them off in different orientations as well. So if you notice, this is this way, but if you drop it off on number 3, it has to be.
Oh, it's in the other way.
Right? So the drop-off areas are also a challenge because there are different orientations for drop-off. They're not the same orientation. So this is a very challenging, missions for our teams this year. It's fun watching our teams trying to do this right now, and I'm seeing a lot of creative solutions. If you look at some of the solutions that are online, they're all EV3s actually. So far we haven't seen a solution using a spike, but my teams are working on spikes. They may switch over to EV3, but we'll see.
And you mentioned that there is a random element, so some randomization, and this is coming from how do we scan where the black and the white cables, the server and the cables are.
That's correct, right? So the white and black. So there's a white and a black for the Caribbean side and a white and black for the Pacific side. You have to programmatically store what you scan. So you need to understand, where is the white going to be dropped off and where's the white going to be dropped off for each side.
Yes, and this happens before every round. The judges, the referees on the table, they will change the position of these blocks. So teams should be prepared for this.
Yeah, I mean, nobody knows what the configuration of the white and black blocks are before the round starts. So, and every round the configuration changes.
Interesting. I think that I've seen in previous competition that there is also a surprise challenge. Like on the day of the competition, there will be some surprise. How does this work?
So usually at the national, so it's really up to the country. But there is a surprise rule at the international level. And here in the U.S., we have it at our national level. At our local levels, we don't introduce a surprise rule. The surprise rule is to give an extra rule to give additional points or maybe additional penalty areas. The organizer of the competition gets to decide what the surprise rule is. And they can implement it the day of the competition without you knowing, and you can maybe get an extra, 15 points for doing moving it to a different area, or whatever the rules say. Now, internationally, they introduced a new way to do the surprise rule. Since it's a 2-day competition, the first day was standard rules, no surprise. Oh well, actually, was there a surprise rule? Yeah, actually, no, there was no surprise rule. Was there a surprise? I'm trying to remember if there was a surprise rule.
I think in Dortmund there was the surprise rule on the second day.
Yeah, the second day. So the second day wasn't really a surprise rule. It was just a totally new set of rules.
It was entirely new competition from my point of view.
Competition. We here in the U.S. call it on the spot challenge, where you get an hour to an hour and a half after you get the new set of rules. Like we could totally change the game with the same game pieces on the mat and give you different set of rules to do. The robot could start in a different position. We may say white and black are reversed. I don't know. We can instead of placing them in the drop-off areas, we can place them on the islands that are on the mat. I don't know. So there's different places there. So we can make up the rules. And, but we want to make it where it's not too difficult, because you only have an hour and a half to do it. But there are probably, different levels of points that you want to be able to see teams to try to get. So there may be some easy points and some hard points to get on the second day. And here in the U.S., the way we're running nationals is the first day we're doing standard rules, 3 rounds. Second day on the spot, 2 rounds. With the new set of rules, and we're adding all the points together to determine the national champion. So we have 5 rounds. Yeah.
Yes. So it's much like lifting weights. You have 2 categories, and you sum the both categories, and you get the champion. So, for example, a surprise rule could be we change the position of the broken cable. It's not initially it's in the Caribbean side, and you get it to the Pacific, or you can change it. That's a surprise. It's something has changed for this. Okay, that's I hope pretty helpful for everybody that's starting the team. Now I just realized that we haven't talked about something very important. You have a team that's preparing for this competition. How would you go about working with this team? Share some insights for other mentors that are also working with teams, what they should do, shouldn't do. What are some good strategies that you follow?
So, so there is a difference between experienced and beginner teams, right? And I'll just start from a beginner team. So you're getting into this, you're looking at this, you're trying to understand, how do I do this, right? So first, obviously, you need to understand the rules. You need to really understand the rules thoroughly and understand the missions that you're going, the points that are on the board. Now, as a beginner team, some teams I advise you don't have to get maximum amount of points. That's not your goal, right? Let's just set some realistic goals for you to achieve, for this year, maybe, right? So your beginner team, if you're ambitious, you try to go for it. But what you need to do is first design a robot. And to design a robot, you have to figure out, what is my robot going to do? Is it going to pick up one at a time? Is it going to pick up multiple at a time? How am I going to read the lines on the table? How I'm going to read objects? So sensor placement is important. Storage of the objects is important. How do you store it? And then can you make things on your robot multifunctional, right? That's where some of the design. So a lot of my teams, and especially my advanced teams, actually took about a month to design the physical parts of the robots, even before touching code, because you can't code something if it isn't functionally going to work. So you need to make sure that you have a functional robot that is sort of ready to go, and then you start coding it. Now you can do some coding, but just to testing, like maybe parts of it out. But really, you need to have a good, solid design of a robot and built robot before you actually start trying to code all the missions. Some basic skills you need to know is you need to know how to line follow. You need to know how to use the sensors. You need to know how to use variables, and you do need to know just basic movements, right? How do I move reliably? So a lot of teams notice when you start using a Lego robot that the robot doesn't do the same thing every time.
It's
right?
a physical thing, like it never does the same time, the same thing.
So there's ways and techniques that you can, what we call error correct, and try to figure out, okay, wait, I'm not in the right position, or I have to correct myself, or so there's a lot of error correcting that needs to happen if you want to try to be more reliable. So all those things need to come into it. And this is a great problem solving, critical thinking, teamwork type of exercise for teams to do. And it takes a good amount of time to figure these challenges out, especially, this junior one's a tough one, and it's going to be good. And I can't wait to see, what the world, what the world teams are doing with this challenge. It's exciting to see.
You're touching a very important point here, that it's a challenging competition, and it's a challenging because it's for the whole world and it takes about a year. And what teams should do is they should identify what's their goal. Okay, so I am first time in this competition. My goal is to get to like 2 missions that I've accomplished, or just part of them. So let's start this year. Let's focus on getting things, because you mentioned a lot of things that you need to know, like line following and techniques for balancing and for autocorrecting. And so how do you build stuff? And as a recommendation to all of the teams, first start with some goal setting. Try to set your goal and to be clear, okay, these are the first thing that we are trying to achieve, right?
Yes. Goal setting and expectations, especially with young kids, you don't want them frustrated. You don't want them to set, expectations that are too high for them to achieve. You want to be able to have a win no matter what. And it's the journey that they take. It's not necessarily a 1-year journey. This is a multi-year journey that you're taking on. And this builds into, future years of robotics, if you're just starting out.
Yes, multi-year journey is what I like here. So you go for the long run. It's a marathon, it's not a sprint. You try for the first year, then the second and the third you get better, and then you probably start winning for 5th year, somewhere around that.
Yeah, somewhere earlier, something. But I'll compare it to sports, right? Baseball, soccer, football, right? Tennis, whatever sport you're doing, there is very unlikely that you take on a sport and be a champion in that sport the first year. You have to practice, you have to work on your skills, you have to work on strategy, technique, and you have to basically hone your craft in that area of expertise, whatever you're doing. So it takes a while, and and they always say practice makes perfect. So that's what you need to do.
And it's also very interesting that you and all the other mentors and coaches are kind of like in sports, where you can't go on the field and do the things for the team. You have to sit on the side and you have to watch. How do you balance this? How do you give them directions without actually stepping in and doing the job?
Yeah, no, that's it's always a challenge. For me, it's easy because I can step back. I basically teach them the skills. I guide them. They ask questions. I give them ideas. I don't do I don't give them the answer necessarily, but I give them options. Give them, how to maybe get through a tough problem that they're try to solve. And that's the whole philosophy of WRO. What we don't like seeing is parents or coaches doing the work, sitting down, coding, sitting down, building. And we see that, and it's a competitive sport and you want your child to do well, but I don't know how much the child is benefit if you're doing the work for them. So our philosophy here and our philosophy for WRO is always, the children do the work and we guide them as much as possible.
That's a great way to summarize our conversation. We let the children do the work and we guide them as much as possible. Thanks, Will. It's been a pleasure to talk with you again on the World Robot Olympiad 2023 Junior Challenge. And I hope that soon we'll get to see the Senior Challenge. What do you think?
Great. All right. Thanks. Yes, definitely.
Thanks for all our viewers and listeners. This has been All Robotics Competition with your host Kiril Mitov and my good friend Will here. Thank you all. I hope it's been very helpful and interesting, and we'll see you in the next video.
Thank you.